Take a long, slow breath and, as you exhale, allow yourself to notice the simple, steady weight of your body. There is a deep comfort in the way you are resting right now, a quiet sensation of sinking just a fraction deeper into your mattress with every passing minute. It is a feeling we often take for granted, but it is actually the most constant relationship you have with the physical world. We often describe this as weight, or perhaps just the tiredness of the day finally catching up to us. But in truth, what you are feeling is a gentle embrace. It is the invisible, soft hand of the universe holding you exactly where you are meant to be. Imagine for a moment that gravity isn't a harsh or demanding force. Instead, try to visualize it as a series of soft, invisible threads. These threads are woven through the fabric of your blankets, through the cells of your body, and through the very air in the room. They are part of a grand cosmic tapestry that connects every single object in existence to every other object. You are not just lying on a bed, you are participating in a universal dance that has been unfolding for billions of years. In the world of physics, there are four fundamental forces that dictate how everything in our reality behaves. There is the strong nuclear force, which acts like a powerful glue holding the centers of atoms together. There is the weak nuclear force, which governs how certain particles decay and transform. And there is the electromagnetic force, which gives us light, electricity, and the ability for molecules to stick to one another. Among these four giants, gravity is the outlier. It is, quite surprisingly, the weakest of them all. To understand just how faint gravity is, think of a small refrigerator magnet. That tiny piece of metal can lift a paperclip off a table, easily defeating the gravitational pull of the entire planet Earth with almost no effort at all. And yet, despite its relative weakness, gravity possesses a quality that the other forces do not. It has the longest reach in the cosmos. While the nuclear forces only operate over distances smaller than a single atom, and electromagnetism can be shielded or neutralized, gravity is patient and persistent. Its reach is infinite. It stretches out across the cold, silent voids between galaxies, pulling on distant suns and wandering planets with a steady, unyielding grace. It is the architect of the large-scale universe, the force that gathers dust into stars and stars into spiraling galaxies. As you lie here in the stillness, that same infinite force is focused on you. It is the quiet anchor that ensures you are safe and grounded as you drift toward sleep. You don't have to do anything to maintain this connection. You don't have to hold on. The universe is already holding on to you. Let your mind drift downward now, moving past the softness of your sheets and the support of your pillow. Imagine your awareness traveling through the floorboards of your room, through the sturdy foundation of your home, and deep into the cool, dark earth beneath. We are going to explore the source of this gentle pull, the massive protective heart of the world that lies directly beneath your bed. Think of the earth not just as a giant spinning rock, but as a protective magnet for mass. It isn't pulling on metal or iron specifically, but on everything that has substance, every leaf, every drop of water, and every part of you. It is a vast, silent guardian that ensures nothing drifts away into the cold dark of space. As we continue this journey together, if you find peace in these nightly explorations of our universe, you're invited to subscribe to this channel. It is a quiet way to ensure we can meet here again whenever you need rest. And if you feel moved to do so, liking this video helps our small community grow, allowing others who are seeking a moment of stillness to find their way to this sanctuary. But for now, there is nothing you need to do. Just listen and let the information wash over you like a slow-moving tide. Deep beneath your bed, the sheer scale of the world is almost beyond imagination. Scientists have calculated the Earth's mass to be approximately 5.97 sextillion metric tons. That is the number 5 followed by 24 zeros. It is a weight so immense that it curves the very space around it. Every ounce of that mass is working in harmony, pulling inward toward a single central point. This constant inward pull is the reason the Earth is a sphere. In the early days of our solar system, when the Earth was still molten and soft, gravity acted like a pair of giant invisible hands, smoothing out the edges and pressing the matter together from all sides. It sought the shape of ultimate efficiency and balance. Because gravity pulls equally from every direction toward the center, the planet settled into this rounded form. It is the shape of a world held together by its own self-attraction, a celestial hug that keeps everything exactly where it belongs. Even the highest mountains and the deepest ocean trenches are just tiny ripples on the surface of this massive, nearly perfect ball. You can feel this mass right now in the way your body sinks into your mattress. You are being cradled by the weight of an entire world. It is a firm, steady reassurance that you are grounded, that you are part of something much larger and incredibly stable. But the Earth's reach does not end at the soil or the sea. Gravity is not a force that simply stops at the surface. It is a field that extends outward, growing thinner but never truly vanishing. As we move our awareness back up from the dense, hot core of the planet, through the heavy layers of rock and the cool crust, we pass through the surface and into the space just above us. Here, gravity performs one of its most vital tasks, holding on to something so light and ethereal that it would otherwise vanish in an instant. It is the invisible blanket that keeps us warm and allows us to breathe, tucked neatly around the planet by that same persistent pull. Imagine the air around you. It feels like nothing, doesn't it? It is so light and transparent that we often forget it is there at all. But this air is a physical thing, a delicate mixture of nitrogen, oxygen, and trace gases swirling in a constant gentle dance. Without the persistent pull of gravity, this invisible blanket would simply drift away. It would dissipate like a puff of smoke in a breeze, lost forever to the vast, cold vacuum of the surrounding universe. But the Earth is a careful guardian. It holds this atmosphere close, tucking it tightly around the planet's surface. As you lie there, breathe in slowly and deeply. Feel the coolness of the air entering your lungs. This very breath is held here for you by the weight of the world beneath you. Gravity ensures that the oxygen we need doesn't float off into the void, keeping it pressed against the crust in a layer that is, in the grand scheme of the cosmos, incredibly thin, yet perfectly sufficient. If you were to rise up from your bed, drifting higher and higher, you would feel the air begin to change. It becomes thinner, colder, and more silent. You would pass the clouds, those heavy bundles of water vapor, also held in place by the Earth's pull. You would pass the altitude where the great silver birds of commerce fly, and still the air would be there, though much more sparse. Eventually, you would reach a threshold known to scientists as the Kármán line. This is the invisible boundary located approximately 62 miles above the Earth's surface. It is often cited as the edge of space, the point where the atmosphere becomes too thin to support an airplane's wings. But even here, at the very doorway to the heavens, gravity remains the absolute ruler. It does not simply vanish once you leave the thickest part of the air. It continues to reach out, a long, invisible arm stretching into the darkness, ensuring that even the highest, loneliest molecules of gas remain part of our world. From the Kármán line, the view is breathtakingly peaceful. Looking down, you can see the curve of the Earth, a glowing arc of blue and white. Looking up, the sky is no longer the soft azure we see from our windows. It is a deep, profound velvet black, a darkness so thick it feels like a physical weight, yet it is perfectly still. In this stillness, the stars don't twinkle. They shine with a steady, unwavering light, like distant candles in a vast cathedral. And there, suspended in that beautiful dark, is our most faithful companion. It is a sight that has comforted humanity since the first eyes looked upward in wonder. We move our gaze away from the thin protective shell of our atmosphere and look toward the silver glow of the moon. It sits there, silent and serene, seemingly drifting, yet it is bound to us as surely as the very blankets that cover you now. As we leave the edge of our air behind, we begin to realize that the dance of gravity is not just happening here on Earth, but is a conversation taking place across the great, silent reaches of space. The moon is more than just a light in the window. It is our silent partner in the night sky. It has been our constant companion for billions of years, a pale, watchful presence that shares our journey through the stars. When you look at it from your pillow, it can feel small enough to hold, yet it is a vast world of its own, a sphere of gray stone and ancient dust, hanging in the perfect stillness of the vacuum. To reach it, you would have to travel a staggering distance. On average, the moon sits about 238,855 miles away from us. It is a gap so wide that you could fit every other planet in our solar system, from the massive Jupiter to the ringed Saturn, into the space between the Earth and the moon, and still have room to spare. And yet, despite this immense separation, the moon and the Earth are locked in a deep, invisible embrace. Gravity bridges that 250,000-mile void effortlessly. It is a connection that never breaks, a tether that ensures we are never truly alone in the dark. You can feel the moon's influence most clearly at the edges of our continents where the land meets the sea. Even though the moon is far away, its gravitational pull is strong enough to tug on the Earth's vast oceans. This pull creates the tides, a phenomenon that has governed the lives of coastal creatures and sailors since time began. Think of the tides as the rhythmic breathing of the Earth's waters. As the moon passes overhead, it gently lifts the sea toward itself, creating a high tide, a long, slow inhalation of the ocean. As the moon moves on, the water recedes, a quiet exhalation back into the deep. This ebb and flow is a heartbeat, a rhythmic reminder that the heavens and the earth are always speaking to one another in the language of gravity. It is a slow, predictable pulse that brings a sense of order to the wildness of the waves, a constant reminder of the moon's gentle persistence. If you watch the moon over the course of a month, you will see it grow and shrink, from a thin sliver of a crescent to a glowing full orb. But have you ever noticed that the features on its surface, the dark patches we call seas, and the bright, rugged highlands, never seem to change their position? We are always looking at the same craters, the same ancient plains of frozen lava. This is one of the most beautiful mysteries of our celestial partnership. The moon never turns its back on us. It keeps its face toward the earth, watching over us as we sleep, just as it has done for eons. There is a profound comfort in this consistency. In a universe that is constantly shifting and expanding, the moon remains a steady, unchanging friend. But this isn't just a coincidence of nature. It is the result of a long, slow process that began when the solar system was young. To understand why the moon always shows us the same face, we have to look deeper into the way gravity acts. Like a soft, persistent hand, slowing things down over billions of years and bringing them into a state of perfect, quiet harmony. It is a story of how two worlds found a way to move together in a synchronization that feels less like physics and more like a cosmic agreement. This eternal gaze is known by scientists as tidal locking. You might think of it as a cosmic hug, a way for gravity to steady two bodies so they can move in perfect unison, never losing sight of one another. In the very early days of our solar system, billions of years ago, the moon likely spun much faster than it does now. Back then, an observer on Earth would have seen the moon's entire surface over time as it tumbled through the void. But gravity is a patient and persistent force. Just as the moon's gravity pulls on our oceans to create tides, the Earth's immense gravity pulled on the solid body of the moon. This pull created tiny bulges in the moon's rocky crust, stretching it ever so slightly into an oblong shape. As the moon rotated, these bulges were constantly being dragged and reshaped by the Earth's relentless grip. This process created a kind of internal friction, a gentle, invisible break that worked across the eons. Imagine a spinning top slowly losing its speed as it brushes against a soft velvet surface. Over millions of years, this gravitational friction wore down the moon's momentum, gradually slowing its rotation. Eventually, the rotation slowed so much that it reached a point of perfect balance. It began to take exactly the same amount of time for the moon to spin once on its axis as it does to travel once around the Earth. Today, that period is about 27.3 days. Because these two motions are now perfectly synchronized, the same side of the moon is always angled toward us. It is a state of total quiet harmony, a masterpiece of celestial mechanics that ensures the familiar face of the moon is always there to watch over the night. This friction is a two-way street, though. The moon's gravity is also very slowly breaking the Earth's rotation, lengthening our days by a tiny fraction of a second each century. It is a slow, beautiful dance where both partners are gradually finding their rhythm together, settling into a long-term stability that provides a sense of peace to our corner of the universe. Because of this lock, the far side of the moon remained a complete mystery to humanity for almost all of our history. It was a hidden world tucked away from our sight until we finally developed the technology to send cameras around behind it. But even as we map its hidden craters, the side we see remains our constant, steady companion. As we appreciate this stillness, we begin to drift further away from our local neighborhood. We leave the moon behind in its silver locked embrace and turn our attention toward the deeper reaches of space. The darkness between the worlds is vast, but it is not empty. It is filled with the far-reaching influence of a much greater power. We are moving toward the center of our solar system, toward the great golden anchor that holds everything in its place. The sun is waiting for us, a massive, glowing heart whose gravity is the foundation of our entire existence, guiding every planet in a slow, majestic circle through the stars. We leave the quiet of the Earth-Moon system and prepare to meet the giant that keeps the entire system from drifting away into the dark. As we drift toward the center of our solar system, the light grows warmer and the silence feels more profound. We are approaching the sun, the great golden anchor of our world. It is difficult to truly grasp the scale of this star. In the vast family of the solar system, including all the planets, the hundreds of moons, and the millions of asteroids and comets, the sun is the undisputed master. It contains roughly 99.8% of the total mass in our entire solar system. Think about that for a moment as you settle deeper into your pillows. If you were to put everything in the solar system on a giant scale, the sun would take up almost the entire space, leaving only a tiny, dusty corner for everything else we have ever known. Every mountain on Earth, the massive clouds of Jupiter, and the icy rings of Saturn are all part of that tiny remaining fraction of a percent. We are all, in a very literal sense, living in the sun's backyard, held close by its massive presence. Because the sun is so incredibly heavy, its gravitational grip is equally immense. If you could somehow stand on its glowing surface, you would feel a pull 28 times stronger than the gravity you feel right now as you lie in your bed. On Earth, gravity gives you your weight, but on the sun, that weight would be multiplied until you felt as heavy as a large vehicle. But from our safe distance, this power doesn't feel like a crushing weight. Instead, it feels like a soft, steady hand guiding our planet through the dark. It is the sun's gravity that acts as an invisible thread, preventing the Earth from wandering off into the cold, lonely reaches of interstellar space. It keeps us tucked in, right where the temperature is just right for life to flourish, like a parent keeping a watchful eye on a child in a vast park. This massive pull holds the entire solar system in a slow, majestic spin. It is a cosmic carousel that has been turning for 4.5 billion years, a rhythm so steady and ancient that it provides the ultimate foundation for our concept of time. Every year that passes is simply one more graceful loop around this central fire. The sun's gravity reaches out for billions of miles, whispering to the most distant icy rocks at the edge of the system, telling them where to go and how to move. It is the conductor of a grand silent orchestra, ensuring that every planet, moon, and grain of dust stays in its proper place. And yet, there is a mystery in this movement. If the sun is pulling on us with such incredible strength, 28 times stronger than our own world's pull, why don't we simply fall into it? Why doesn't the Earth or any other planet get sucked into that golden furnace? It seems like a cosmic magic trick, a way to stay suspended in the void forever, always being pulled inward but never actually hitting the center. To understand how we stay safe in our orbit, we have to look at the delicate balance between speed and pull, a secret of the universe that allows us to fly through the vacuum without ever losing our way. This balance is what we call an orbit, and it is perhaps the most beautiful coincidence in all of physics. To understand why we don't fall into the sun, imagine you are holding a small, smooth stone. If you simply let go, the stone falls straight down to the ground. If you throw it forward, it travels in a gentle curve before landing in the grass. Now, imagine you could throw that stone with such incredible, impossible speed that the curve of its fall perfectly matches the curve of the earth beneath it. The stone would keep falling, pulled downward by gravity, but it would never actually hit the ground. It would simply keep going, circling the world in a loop that never ends. This is the secret of the perpetual fall. This is what an orbit really is. It isn't a state of floating or being weightless in the way we often imagine. Instead, it is a delicate, beautiful dance, a perfect balance between two opposing forces. On one side, you have forward momentum, the natural tendency of an object to keep moving in a straight line through the void. On the other side, you have the constant inward pull of gravity. When these two forces are perfectly matched, the object enters a stable orbit. It is moving fast enough to miss the planet it is falling toward, but not so fast that it escapes into the deep dark of the stars. It is tucked into a permanent path, a rhythmic journey through the silence. Think of the International Space Station drifting quietly above us while the world below sleeps. We often see videos of astronauts floating inside, moving as if they are in a dream. It is easy to assume they are so far away that Earth's gravity can no longer reach them. But in reality, at that height, gravity is still very strong, about 90% of what we feel here on the surface. The reason the astronauts float is that the entire station is falling. It is plummeting toward the Earth at 17,500 miles per hour. Because the station is moving forward so fast, it moves sideways just as much as it falls downward, tracing the curve of our planet. Because everything inside the station is falling at that same incredible speed, the astronauts feel no weight. They are in a constant, peaceful state of free fall, gliding through the thin upper reaches of the atmosphere, missing the Earth's surface by thousands of miles every hour. It is a high-speed tumble through the dark that feels as still and calm as a long night's rest. This same principle of balance applies to every planet in our solar system. It is why the moon stays with us, and why the Earth remains at a safe, warm distance from the sun. Each planet has found its own unique rhythm, its own perfect speed that keeps it from either crashing into the solar fire or drifting away into the freezing void. This balance began billions of years ago, when the solar system was just a swirling cloud of dust and gas. Over time, the chaos settled into the orderly paths we see today. The inner planets, those rocky worlds closest to the sun's heat, must move the fastest to maintain this balance, braving the strongest parts of the sun's gravitational pull. As we move inward from our own blue home, we find the worlds that live in the sun's immediate glow. These are the small, sturdy survivors of the inner solar system, Mercury and Venus. They are bound to the sun by threads of gravity much tighter than our own, moving through the void with a determined ancient speed. To understand how gravity shapes these worlds, we must look at how their own mass dictates their destiny, and how even a small difference in size can change the very nature of a planet's surface. Imagine for a moment that you are standing on the surface of Mercury, the smallest of the major planets, and the one that huddles closest to the sun's immense warmth. It is a quiet, scorched world, heavily cratered and ancient, resembling our own moon in many ways. Because Mercury is so small, it possesses far less mass than the Earth, and mass is the silent engine that generates gravity. If you were to step out onto its sun-drenched plains, you would find that the planet's pull is remarkably gentle. Mercury's gravity is only about 38% of what you feel right now as you lie in your bed. If you weighed 100 pounds on Earth, you would weigh only 38 pounds there. Every movement would feel light and effortless, as if the very air was helping to lift you up. You could leap with the grace of a dancer, drifting slowly back down to the dusty ground in a long, peaceful arc. It is a place where the heavy burdens of weight seem to dissolve, leaving you feeling as light as a whisper in the cosmic dark. Just a little further out from the sun, we encounter Venus, a world of brilliant reflective light. Venus is often whispered about as Earth's twin, a title it earned because of its striking physical similarities to our own home. While its surface is hidden beneath a thick, perpetual veil of golden clouds, its internal structure is very much like Earth's. It is nearly the same size and has nearly the same density, which means its gravitational signature is almost a perfect match for ours. If you were to stand on the surface of Venus, you would feel 91% of the gravity you feel on Earth. To your muscles and your bones, it would feel almost exactly like home. This gravitational similarity is a rare thing in our solar system. It is a deep vesical resonance between two worlds that grew up side by side in the sun's glow. Despite the vast differences in their atmospheres and temperatures, the Earth and Venus pull on the fabric of space with almost the same strength, creating a familiar sense of stability for any object resting upon them. It is as if these two planets were cast from the same cosmic mold, mirroring each other's weight in the silent vacuum. As we leave these two inner neighbors behind, we drift past our own familiar blue world and continue our journey toward the outer reaches of the solar system. The light of the sun begins to soften, and the intense heat of the inner circle fades into a cool, steady glow. We are moving toward a world that has captured the human imagination for centuries, a place of red deserts, ancient dry riverbeds, and towering peaks. This is Mars. Here, the rules of gravity shift once again, moving away from the heavy familiarity of Earth and Venus and back toward a lighter, more ethereal experience. As we descend toward the rust-colored dust of the Martian plains, we prepare to see how a smaller world uses its modest gravity to build monuments that dwarf anything found on Earth. Relax your shoulders, let your breath be slow and even as we transition from the golden clouds of the twin world to the calm red silence of the desert planet. Imagine your boots touching down on the soft oxidized dust of the Martian surface. The color is a deep, soothing ochre, like the embers of a dying fire. There is a profound stillness here, a quiet that stretches across vast, wind-swept plains and ancient, slumbering craters. As you take your first step, you notice something remarkable. The ground doesn't pull at you with the same insistence you've known all your life. On Mars, the gravity is only about 38% of what it is on Earth. Your body feels unnervingly light, as if you are moving through a gentle, invisible liquid that supports your every move. If you were to gather your strength and leap, the result would be a slow-motion ascent. You could jump 3 times as high as you ever could on Earth, hanging in the thin pinkish air for several seconds before gravity gently coaxes you back down to the rust-colored ground. It is a world where every movement is graceful, where the simple effort of a walk becomes a rhythmic, low-gravity glide. This lightness isn't just a novelty for a traveler. It is the very force that has shaped the spectacular and dramatic landscape of the red planet over billions of years. Because the downward pull is so much weaker here, the crust of Mars can support much heavier loads than the crust of the Earth. This is the secret behind the existence of Olympus Mons, the largest volcano in the entire solar system. Imagine a mountain so vast that its base would cover the entire state of Arizona, its peak reaching 21 kilometers into the sky, nearly 3 times the height of Mount Everest. On Earth, a mountain of this size would be physically impossible. It would be crushed by its own immense weight, its base sinking into the mantle under the relentless pressure of our planet's stronger gravity. But on Mars, the gentler pull allows the rock to stack higher and higher, reaching toward the stars in a magnificent display of geological ambition. It stands as a silent, towering monument to what happens when gravity lets go of its tight grip, allowing the land to rise toward the heavens. As we lift our gaze from the towering, frozen slopes of Olympus Mons and look toward the darkening horizon, the red landscape begins to fade into the distance. We are moving away from the solid ground once more, venturing into the wide, dark gap that lies between Mars and the giant planets of the outer solar system. This region is not empty space, but a vast, scattered kingdom of ancient stones and silent travelers. We are crossing the threshold into the asteroid belt. It is a place of fragments and leftovers, a celestial archive of the solar system's earliest days, where millions of rocky bodies drift in a perpetual quiet loop around the sun. As we drift into this field of orbiting debris, we begin to see how gravity doesn't just build worlds, but sometimes it acts as a sculptor of a different kind, one that prevents things from coming together. The space around us feels even more expansive now, the silence even deeper, as we enter the realm of the rocks that never quite became a home, held in a delicate balance by the distant tug of the giants. We find ourselves now in a vast, sprawling gallery of cosmic artifacts. This is the asteroid belt, a wide ring of debris that sits comfortably between the orbits of Mars and Jupiter. In popular stories, this place is often depicted as a dense, chaotic field of tumbling rocks where ships must weave and dodge to survive. But the reality is much more peaceful, much more aligned with the slow, rhythmic breathing of the universe. In the asteroid belt, the distances between objects are immense. If you were standing on one asteroid, the next would be so far away it would likely appear as nothing more than a faint, steady star in the distance. There is a profound sense of solitude here, a quietness that stretches for millions of miles. These rocks are the building blocks of a world that never was. Long ago, when the solar system was a swirling cloud of dust and gas, the materials in this region were trying to come together, pulled by their own mutual attraction to form a fifth rocky planet. They were reaching for one another in the dark, attempting to coalesce into a sphere of stone and metal, much like Earth or Mars. But they were never allowed to complete that journey. Just beyond them, the giant planet Jupiter was already taking shape, growing into a massive gravitational titan. Jupiter's gravity is so powerful that it acted like a cosmic stirrer, constantly tugging at these fragments, nudging them out of their paths, and keeping them moving too fast to settle down. Every time these rocks tried to merge, Jupiter's distant influence would pull them apart again, leaving them scattered in this eternal holding pattern. It is a poignant thought, a collection of potential that was never realized, held in a state of permanent childhood by the gravity of a neighbor. Because of this, the asteroid belt remains a time capsule, preserving the original materials of the solar system exactly as they were billions of years ago. Despite the millions of individual pieces that make up this belt, from tiny grains of dust to the dwarf planet Ceres, the actual amount of matter here is surprisingly small. If you were to gather every single asteroid, every pebble, and every mountain-sized rock in this entire vast region, and smash them all together into one single body, it would still be remarkably tiny. The total mass of the entire asteroid belt is only about 4% of the mass of our moon. It is a reminder of how much of our solar system is actually made of beautiful empty space, and how thinly the seeds of planets are sometimes spread. As we continue our slow drift outward, the light of the sun begins to feel a little cooler, a little more distant. The rocks of the belt fall away behind us, returning to their lonely orbits. Ahead, something immense is beginning to dominate the view. It is a presence you can feel before you even see it, a heavy authoritative pull that commands the movement of everything in this part of the sky. We are approaching the king of the planets, the great guardian and architect of the solar system. The gas giant Jupiter looms before us, its swirling bands of cream and ochre spinning in a slow, majestic dance, its gravity reaching out like a soft, irresistible hand to guide us closer to its massive heart. We are entering the domain of a giant that has protected our small blue home for eons. As we drift into the orbit of this colossal world, you might feel a deep sense of security. Jupiter is often called the great vacuum cleaner of our solar system, a title it has earned through billions of years of silent, steadfast service. Its gravity is so immense, so commanding, that it acts as a cosmic shield for the inner planets, including our own. Imagine a stray comet, a wanderer from the cold, dark edges of the outer reaches, hurtling inward toward the warmth of the sun. Without Jupiter, many of these icy visitors might find their way toward the path of the Earth. But as they approached the giant, Jupiter's massive gravitational field reaches out like a gentle but firm hand. It nudges them, bending their paths and flinging them safely away into the deep void, or sometimes pulling them into its own thick, swirling atmosphere where they vanish without a trace. It is a quiet, constant protection that has allowed life on Earth the long, uninterrupted stretches of peace it needed to grow and flourish. Knowing that this giant stands guard in the darkness makes the vastness of space feel a little more like a home. Around this giant, gravity has woven an incredibly complex and beautiful web. Jupiter does not travel through the stars alone. It carries with it a miniature solar system of its own. At the latest count, astronomers have identified 95 moons orbiting this world, each one caught in the giant's gravitational embrace. They range from massive icy worlds with hidden oceans to tiny, irregular fragments of rock that look like drifted petals in the wind. These 95 moons move in a perfectly synchronized dance, some circling close to the planet's colorful clouds, and others tracing wide, slow loops millions of miles away. They are all held in place by that same invisible thread, a tapestry of motion that never tires and never falters. You can visualize these moons as small glowing lanterns, each one tethered to the center by the weight of the giant, creating a rhythmic harmony that has persisted for eons. As we move past the outermost moons of Jupiter, the space around us grows quiet once more. The giant begins to recede, its bands of orange and white softening into a single point of steady light behind us. We are traveling further now, into the realm where the sun's light becomes a pale silvery glow, casting long and cooling shadows across the vacuum. The silence here is deep and restorative, a velvet blanket that stretches out in every direction. But soon, a new radiance begins to shimmer on the horizon. It is a glow unlike any other, soft, golden, and impossibly wide, stretching across the dark like a bridge of dust and light. We are approaching Saturn, a world that wears its gravity like a crown of jewels. While Jupiter uses its power to protect the solar system and to gather its many moons, Saturn uses its gravity to create the most delicate and beautiful display in the known universe. Ahead, the rings begin to come into focus, a flat, shimmering disk of ice and shadow, waiting for us to see how gravity maintains such perfect, fragile order in the cold of the deep night. As we draw nearer to Saturn, the shimmering bridge of light reveals its true nature. What looked like a solid, glowing disk from a distance is actually a vast, swirling collection of billions of individual particles. Most of them are made of pure water ice, frozen into shapes that range from the size of a tiny snowflake to the size of a mountain. They catch the faint, distant light of the sun, reflecting it back into the darkness like a field of diamonds scattered across a velvet cloth. Each one of these icy fragments is caught in Saturn's gravitational pull, traveling in a path so precise and so flat that the entire ring system, despite being hundreds of thousands of miles wide, is incredibly thin. If you were to look at the ring's edge on, they would almost disappear, a testament to the eddy, flattening hand of gravity that has pressed them into this perfect, level plane over eons of time. Within this intricate lace of ice and dust, there are hidden guardians. We call them shepherd moons. These are small, humble worlds that orbit within or just outside the ring gaps, acting as the keepers of order. Imagine a moon like Pan or Daphnis, tiny and pale, gliding through the dark channels between the rings. As they move, their gravity acts like a gentle, invisible broom. This is a process of constant, quiet maintenance. If a stray particle of ice begins to drift away from its companions, wandering into a gap where it doesn't belong, the shepherd moon's gravity reaches out with a soft nudge. It pulls the stray back into line, or perhaps slows it down just enough to return it to the main body of the ring. This constant, quiet herding is a beautiful example of how gravity creates structure out of potential chaos. Without these moons, the rings would slowly spread out and fade away, losing their sharp edges and clear divisions. Instead, the gravity of the shepherds keeps the edges of the rings crisp and the gaps wide and empty, like a well-tended garden path. It is a slow, rhythmic process that happens in total silence, a celestial choreography that has been performing for millions of years. Watching this from afar, one can feel the immense patience of the universe, where even the smallest moon has a role to play in maintaining the beauty of the whole. There is a profound sense of peace in knowing that even in the cold reaches of space, there is a force that herds the small and the wandering back into the fold. As we leave the golden realm of Saturn behind, the majestic rings begin to shrink, becoming a thin, glowing line against the blackness. The silence here feels heavier now, more profound, as we drift further into the outer reaches of the solar system. The golden and amber hues of the gas giants are replaced by something cooler, something more serene. The space ahead is vast and lonely, but it is not empty. We are moving toward the ice giants, two massive worlds of deep, tranquil blue that sit on the very edge of the sun's family. Here, in the dim light of the far frontier, gravity works in a different way, steadily holding on to worlds that are cold, mysterious, and full of secrets. We turn our gaze toward Uranus and Neptune, where the blues of the deep ocean meet the frozen stillness of the void, and we prepare to see how gravity guided us to discover these worlds before we even knew they were there. The deep blues of the outer reaches of our solar system carry a different kind of silence. Out here, billions of miles from the sun's warmth, gravity feels cold, steady, and immensely patient. The light is dim, like the moments just before dawn or just after dusk, and the two great ice giants, Uranus and Neptune, hang in the void like polished gemstones. These worlds are vast, composed of swirling fluids and ices, yet they possess a serenity that invites us to simply watch and breathe. As we approach Uranus, you might notice something peculiar about the way it moves. While most planets in our neighborhood spin like upright tops, tilted only slightly, Uranus is different. It orbits the sun on its side, rolling along its orbital path like a ball. This unusual orientation gives it a sense of quiet rebellion, as if it is reclining in the dark. Scientists believe this is the result of a profound gravitational event from the solar system's violent youth. Long ago, a massive object, perhaps twice the size of Earth, may have collided with Uranus. The sheer gravitational force of that encounter knocked the planet over, forever changing its path. It is a reminder that while gravity usually brings order, it also carries the memory of ancient transformative moments. Even now, in its tilted state, Uranus remains perfectly balanced, its moons orbiting around its equator like a vertical bullseye, all held in place by that same unwavering pull. Further still, we find Neptune, a world of deep royal blue. Neptune is a place of incredible winds and hidden depths, but its most fascinating story is how we came to find it. Unlike the other planets, which were discovered by eyes peering through telescopes, Neptune was discovered by the mind. In the 19th century, astronomers noticed that Uranus wasn't following the path that the laws of physics predicted. It was wobbling, drifting slightly out of place, as if something invisible were tugging at it. They trusted the math of gravity so deeply that they didn't assume the laws were wrong. Instead, they assumed there must be another world further out, exerting its own pull. Mathematics pointed the way to a specific spot in the dark, and when telescopes were finally aimed there, Neptune was found almost exactly where the numbers said it would be. It was a triumph of gravitational science, a proof that even when we cannot see the source, we can feel its influence through the way it moves the things around it. There is a comfort in that thought as you lie here in the dark, that there are invisible connections and steady forces guiding everything, even when they are hidden from view. Now, we begin to drift beyond the last of the great planets. The sun has become little more than a very bright star behind us, its intense heat replaced by the soft, ambient glow of the Milky Way. We are crossing the threshold of our solar neighborhood, moving out into the vast interstellar spaces between the stars. The silence here is even deeper, a velvet expanse that stretches for light years. But even in this emptiness, gravity is at work, drawing together the wandering ghosts of the universe. We are moving toward the giant molecular clouds, the great nurseries of the cosmos, where the weight of the darkness itself begins to press inward, preparing to light the fires of new suns. In these cold, misty cradles of gas and dust, we will see how gravity acts as the ultimate architect of life and light. As we drift into these vast, shadowed nurseries, the scale of what we are seeing begins to settle over us. These are the giant molecular clouds, the great silent cradles of the universe. To our eyes, they may look like holes in the tapestry of the night sky, dark, empty voids where no stars shine. But in reality, they are filled with the raw materials of everything that has ever existed. They are composed mostly of hydrogen, the simplest and oldest element, mixed with a fine, cold mist of cosmic dust. These clouds are immense, stretching across hundreds of light years, and they are the coldest places in the galaxy, sitting just a few degrees above the absolute stillness of zero. In this deep, frigid quiet, gravity is the only thing that moves. It is a patient architect, never in a hurry, waiting for the perfect moment to begin its work. Within the cloud, the gas and dust are not spread perfectly evenly. There are always small regions where the atoms are slightly more crowded together. Gravity senses these tiny variations, these subtle whispers of mass, and it begins to pull. It is a very soft, very slow tug, drawing the surrounding gas toward those denser pockets. Over thousands of years, what began as a mere suggestion of a shape becomes a definite core. As more and more matter is drawn in, the gravity of the core grows stronger, and the collapse begins to accelerate. Imagine a vast invisible hand gently squeezing a ball of mist until it becomes smaller and smaller. This is the perpetual fall on a grand scale. Every atom of hydrogen is falling toward the center of the core, and as they fall, they pick up speed. They begin to bump into one another, crowding closer and closer, and this friction starts to generate heat. What was once a freezing pocket of the void begins to warm, glowing with a faint infrared light that we cannot see with our eyes, but can feel as a soft cosmic pulse. The core continues to shrink, and the heat continues to rise. It becomes a protostar, a sun that hasn't quite woken up yet. It is still wrapped in a thick, protective blanket of dust and gas, hidden away from the rest of the galaxy. Inside this cocoon, the pressure becomes unimaginable. The atoms at the very center are being crushed together with such immense force that they can no longer remain separate. Finally, at a temperature of about 15 million degrees, the magic happens. The hydrogen atoms are forced to fuse together, transforming into helium and releasing a tremendous burst of energy. This is the moment of ignition, the birth of a star. The darkness is suddenly pushed back as a new light flares into existence. This spark of nuclear fusion is what allows a star to shine, sending light and warmth out into the cold reaches of space. But even in this moment of incredible power, there is a profound sense of peace. The star does not explode or fly apart. Instead, it finds its balance. The energy pushing outward from the core perfectly matches the gravity pulling inward. The life of a star is defined by this beautiful, steady stand-off. It is a state of constant, quiet grace that will last for millions or even billions of years. As you settle deeper into your pillows, think of this balance, the way a star can be both a raging furnace and a stable guiding light, held together by the same gentle force that keeps you tucked safely in your bed. We are watching the universe turn its own weight into light, a slow and rhythmic process that ensures the night sky is never truly empty. This balance is the foundation of everything, a peaceful equilibrium that allows the cosmos to flourish in the light of its own creation. This delicate state of existence has a name in science: hydrostatic equilibrium. It is a long technical term for something that is, at its heart, a very simple and peaceful standoff between two powerful neighbors. Imagine a great glowing sphere where everything is perfectly still and perfectly balanced. On one side of this balance, you have the weight of the entire star, countless tons of gas, all trying to fall toward the center. This is gravity's work. It is relentless and patient, always pulling inward, trying to squeeze the star into the smallest possible space. If gravity were the only force at play, the star would continue to collapse until it became nothing more than a tiny, dense point. But inside the star's core, a different kind of power has awakened. The nuclear fusion we spoke of creates an intense outward pressure, You can think of it as a soft but incredibly firm wind blowing from the inside out. This heat and light want to expand, pushing against the crushing weight of the star's outer layers. It is a constant, radiant energy that resists the squeeze of gravity. These two forces, the inward pull of gravity and the outward push of heat, meet in the middle and decide to rest. Neither one wins, and because of that, the star becomes a stable, glowing sphere. It is as if the star has found its own internal peace, a state of quiet grace where it isn't shrinking and it isn't expanding. It is simply being. This is the main sequence of a star's life, a long period of maturity where it shines with a steady, unwavering light. A star spends the vast majority of its life in this stable, glowing state. For a star like our sun, this quiet equilibrium will last for about 10 billion years. Smaller stars can remain in this peaceful standoff for even longer trillions of years, burning their fuel so slowly and gently that they seem almost eternal. During this time, the star is a reliable source of warmth for any worlds that might be huddled nearby. It is a cosmic candle that refuses to flicker, held together by its own weight and kept alive by its own inner fire. When you look up at the night sky, almost every point of light you see is a star currently enjoying this state of hydrostatic equilibrium. They are the anchors of the universe, providing a sense of permanence in a void that is always in motion. As you settle deeper into your blankets, consider the stillness of that balance. The star is not rushing. It is taking its time, burning through its fuel with a rhythmic, measured pace. However, as we look closer at these stable beacons, we begin to notice that the story of a star is often a shared one. While our own sun lives a relatively solitary life, many other stars in the galaxy prefer company. They do not drift through the darkness alone. Instead, they find partners, bound together by the same invisible threads of gravity that keep their own cores stable. They begin a slow, graceful dance around one another, creating a partnership that defines their entire existence. Imagine two great lanterns suspended in the dark, moving in a slow and rhythmic circle. This is the reality for much of our universe. While we are used to our single sun rising and setting alone, many worlds wake to the sight of two suns, or even three, casting overlapping shadows across the landscape. These are binary star systems, celestial partnerships where gravity has tied two stars together in a lifelong waltz. It is a beautiful thought that even in the vast isolation of space, so many stars have a constant companion to share the journey with. You might be surprised to learn that our sun is actually a bit of an outlier. When you look up at the tapestry of the night sky, your eyes are often seeing a single point of light that is, in reality, two or more stars huddled close together. Astronomers estimate that over half of the stars in our galaxy are part of multiple star systems. From our distant perspective on Earth, their lights merge into one soft glow. But if we were to travel closer, we would see them spinning around one another, held in a delicate gravitational embrace that prevents them from drifting apart. They do not simply orbit each other as if one is the master and the other the servant. Instead, they both revolve around an invisible point between them known as the barycenter. Think of the barycenter as the cosmic center of mass, an invisible fulcrum where their two weights find a perfect, steady balance. If one star is much larger than the other, the barycenter sits closer to the heavy one, much like a playground seesaw, where the heavier person must sit closer to the middle to keep things level. They spin around this empty patch of space, a silent, mathematical heart that keeps their motion orderly and predictable. It is a testament to the fairness of gravity. Every object, no matter how large or small, must contribute its weight to the balance of the system. In some cases, these stars are so close that they begin to share their outer layers of gas, a soft exchange of starlight between partners. In others, they are separated by vast distances, taking hundreds or even thousands of years to complete a single circle. Regardless of the distance, the rhythm remains the same, a slow, patient pulse of motion that has continued for billions of years. As you breathe in and out, you can almost imagine that same rhythmic pulse, a steady movement that requires no effort, just a quiet surrender to the natural laws of the universe. But as we watch these pairs and triplets of stars dancing in the dark, we begin to realize that they are not just isolated groups. If we pull back, moving our perspective further and further away, we see that these dancing pairs are part of something much larger. The darkness between the stars begins to fill with a faint milky glow. We are no longer looking at individual lights, but at a grand swirling river of stars. The binary systems, the solitary suns, and the glowing nebulae are all being swept up into a majestic structure that spans the horizon of the mind. We are leaving the neighborhood of individual suns and entering the realm of the galaxy itself. The great rotating spiral we call the Milky Way. Imagine the Milky Way not as a chaotic swarm, but as a grand rotating spiral. It is a luminous disk of light, a gathering of some 200 billion stars. Each one of those stars, like our own sun, has its own story, its own planets, and its own quiet place in the structure. From our vantage point inside one of its arms, it looks like a faint band of milk spilled across the night sky, but from above, it would look like a magnificent cosmic whirlpool, frozen in a slow, graceful turn. To understand the sheer scale of our home, consider that the Milky Way is roughly 100,000 light years across. If you could travel at the speed of light, fast enough to circle the Earth 7 times in a single second, it would still take you 100,000 years just to cross from one edge of the galaxy to the other. It is a distance so vast that it transcends human measurement, yet gravity holds every inch of it together with effortless ease. As this great wheel turns, you might wonder why the stars on the outer edges don't simply fly off into the dark, empty void of intergalactic space. After all, they are moving at incredible speeds. The answer lies in that same gentle, persistent thread we have been following. Gravity acts as a silent shepherd, keeping the stars in the spiral arms tethered to the collective mass of the galaxy. It is a collective effort. Every star, every cloud of gas, and every speck of dust contributes its own small pull, creating a massive, shared gravitational field that keeps the entire family of stars together. The spiral arms themselves are not solid structures, like the blades of a fan. Instead, they are more like ripples in a pond, or waves of density moving through the stars. As the stars drift through these arms, they slow down just slightly, lingering in the glow before moving back out into the quieter spaces between the spirals. It is a constant rhythmic flow, a slow motion migration that has been happening for billions of years and will continue for billions more. Take a slow breath, feeling the stillness of your own room, and compare it to the silent, steady rotation of the galaxy. Even as you rest, you are traveling. You are part of this grand motion, circling the distant center of the Milky Way at hundreds of thousands of miles per hour. Yet you feel nothing but the soft weight of your blankets. Gravity ensures that this journey is smooth, steady, and safe. And now, we begin to turn our attention away from the outer suburbs where our sun resides. We start to drift inward, past the crowded clusters of stars and the glowing clouds of gas, moving toward the very center of the spiral. The light here becomes more concentrated, the stars more densely packed as we approach the mysterious heart of our galaxy, a place of immense power and profound silence. As we move deeper into the heart of the Milky Way, the space between the stars begins to shrink. The sky here is no longer a dark velvet, but a brilliant tapestry of gold and white, where suns are packed so tightly together that they illuminate the cosmic clouds from within. At the very center of this glowing metropolis sits the galaxy's most profound mystery, a presence that is both incredibly massive and remarkably quiet. This is Sagittarius, a star, the gentle giant that serves as the ultimate gravitational anchor for our home in the stars. It is a supermassive black hole, a point in space where gravity has achieved its most concentrated form. To visualize the power of this anchor, imagine taking 4 million suns, 4 million stars exactly like our own, and gathering them all into one place. Now, imagine all that immense mass being tucked into a space no larger than the distance between our sun and the planet Mercury. It is a density that defies our everyday experience, yet it is this very concentration that allows it to hold the entire galaxy together. From this central point, gravity radiates outward, reaching across the vast distances to keep the 200 billion stars of the Milky Way in their graceful circular dance. Despite its reputation in stories, a supermassive black hole like Sagittarius A star is not a cosmic vacuum cleaner reaching out to pull things in. Instead, it is more like a grand conductor. The stars near the center don't fall into it. They orbit it, moving in swift, elegant loops like dancers around a maypole. Some of these stars are moving at millions of miles per hour, yet because of the immense scale of the galaxy, their motion appears as a slow, eternal waltz. This central anchor provides the stability required for a structure as large as a galaxy to exist. It is the weight at the center of the wheel, the point of stillness around which everything else turns. As you lie there, feeling the steady pull of the earth, you can imagine this much larger pull far away. It is a comforting thought that even something as vast and complex as a galaxy has a center, a heart that keeps everything in its proper place. But this brings up a curious question. If the center is pulling so steadily and the galaxy is spinning, why don't the spiral arms wind up tighter and tighter over time? If you were to stir a cup of cream into coffee, the spirals would quickly vanish into a blur. Yet, our galaxy has kept its beautiful, distinct spiral shape for billions of years. To understand why the arms don't simply wrap around the center like thread on a spool, we have to look at the way gravity creates a different kind of structure, one that isn't solid, but rather a moving wave of light and energy. To solve the mystery of why the galaxy doesn't simply wind itself up into a tight, unrecognizable blur, we look toward a concept known as density waves. You can think of these as the gentle traffic jams of the cosmic highway. Imagine for a moment that you're looking down at a long, winding road from high above. Every so often, you notice a section where the cars have bunched together. They haven't stopped. They are simply moving a little more slowly through that specific stretch of pavement. As each car reaches this area, it eases off the accelerator, spends a few minutes traveling in the cluster, and then eventually speeds up again as it breaks through to the open road ahead. The traffic jam itself seems to stay in one spot or move very slowly, even though the individual cars are constantly flowing in and out of it. This is exactly what is happening within the spiral arms of the Milky Way. These arms are not solid structures like the spokes of a wooden wheel, nor are they made of a fixed set of stars. Instead, they are regions of higher density, waves of gravity that move through the galaxy at a different speed than the stars themselves. As a star orbits the galactic center, it eventually encounters one of these waves. The collective gravitational pull of the matter already gathered there causes the star to slow down, lingering in the arm for a few million years before finally pulling away and continuing its journey through the lonelier, darker spaces between the spirals. This cosmic crowding has a remarkably beautiful side effect. As vast drifting clouds of hydrogen gas enter these gravitational traffic jams, they are gently squeezed together by the increased pressure of the region. This compression acts as a catalyst, a soft nudge that causes the gas to collapse under its own weight and ignite. This is the moment of creation. The density waves are the nurseries where new stars are born. Because of this intense pressure, many of the stars created in these arms are incredibly massive and hot, glowing with a brilliant, piercing sapphire blue light. These giant stars live fast and die young, often ending their lives before they ever have a chance to drift out of the spiral arm where they were born. This is why the arms of a galaxy appear so much brighter and more vivid than the rest of the disk. They are illuminated by the short-lived glow of youth, like a string of holiday lights marking the path of the gravity wave. As we move away from these bright, bustling lanes of the galactic disk, the scenery begins to change. The crowded, energetic environment of the spiral arms fades behind us as we travel upward and outward, leaving the main plane of the galaxy. We are moving into what might be called the suburbs of the Milky Way, the vast, quiet halo that surrounds the glowing disk. Here, the chaotic birth of new stars is a distant memory, and the environment becomes one of profound age and stillness. In this peaceful expanse, we find the ancient sentinels of the deep, the globular clusters. These are tight, shimmering spheres of light, each holding hundreds of thousands of stars, floating like lanterns in the dark outskirts of our galactic home. Take a moment to visualize one of these globular clusters up close. It is a breathtaking sight, a perfect sphere of light shimmering against the absolute blackness of the galactic halo. From a distance, it looks like a single, fuzzy star. But as you drift closer, it resolves into a dense, sparkling swarm. There are hundreds of thousands, sometimes even 1,000,000 stars, all gathered together in a space that is incredibly small by cosmic standards. If you were standing on a world in the heart of such a cluster, your sky would be a tapestry of light so thick that the concept of a lonely dark night would be entirely foreign to you. The stars would be so numerous and so bright that they would cast shadows on the ground, even in the middle of what should be the night. These clusters are the true elders of our galaxy, while the stars in the spiral arms we just left are often young, vibrant, and short-lived. The stars within these spheres are ancient. They have been burning for 12 or 13 billion years, nearly as long as the universe itself has existed. They are the survivors of the cosmos, having witnessed the birth and death of countless generations of other stars. What keeps them so tightly bound together is nothing more than their own mutual gravitational attraction. In a beautiful, eternal dance, every star in the cluster pulls on its neighbors, and they pull back in return. This collective embrace is so strong that these clusters can survive for billions of years without losing their shape or drifting apart into the void of space. They are self-contained cities of light held together by the very same force that keeps your feet on the ground and your head on your pillow. As you watch them, notice how they move. They do not follow the orderly, flat rotation of the stars in the galactic disk. Instead, the globular clusters inhabit the halo, the vast three-dimensional space surrounding the Milky Way. They orbit the center of the galaxy in great looping paths that take them high above and deep below the spiral arms. They move like a slow-motion swarm of bees surrounding a hive, appearing and disappearing into the darkness of the outer reaches. There are about 150 of these clusters known to be orbiting our galaxy, and each one is a relic of the era when the Milky Way was first coming together, a fossilized record of the early universe. But as we observe the way these clusters and the billions of stars in the disk move, a strange and quiet realization begins to settle in. We can see the stars, the glowing gas, and the drifting dust, and we can calculate how much gravity all that visible matter should produce. Yet, when we look at the speed at which the galaxy rotates, the math simply doesn't add up. The stars at the outer edges are moving much faster than they should be. They are racing at speeds that should cause them to fly off into intergalactic space, like water spinning off a fast-moving wheel. There must be something else there, something we cannot see, an invisible scaffolding that provides the extra gravity needed to hold this entire massive structure together. As you settle deeper into your rest, we begin to look toward the most mysterious substance in the cosmos, the silent glue of the universe. Imagine, for a moment, an invisible hand resting gently on the shoulders of the universe, keeping everything in its proper place. This is what scientists call dark matter, the silent scaffolding of the cosmos. It is perhaps the most mysterious substance in existence, yet it is all around us, filling the vast gaps between the stars and wrapping every galaxy in a soft, invisible embrace. We cannot see it, we cannot touch it, and it does not emit or reflect any light. Yet we know it is there because of the way it speaks through the language of gravity. When astronomers first began to measure the rotation of galaxies like our own Milky Way, they expected to see the stars at the outer edges moving more slowly than the stars near the center, much like how the distant planets in our solar system move more slowly than those close to the sun. But they found something startling. The stars at the very fringes of the galaxy are racing at incredible speeds, so fast that by all the laws of physics we can see, they should be flung away into the darkness. Based only on the visible light from stars, gas, and dust, there simply isn't enough mass to hold them back. And yet, the galaxies remain whole. They do not fly apart. They stay gathered in their beautiful rhythmic spirals year after year, eon after eon. This tells us that there is a vast amount of matter that we cannot see, providing the extra gravitational grip needed to keep the stars in their orbits. This is the dark matter, a quiet, steady presence that outweighs all the visible stars and planets combined by about 5 to 1. It forms a massive, invisible halo around the Milky Way, acting like a cosmic cradle that keeps our galactic home stable and secure. Think of it not as a dark or empty void, but as a supportive structure, much like the air in a room or the water in a deep, still lake. You cannot see the air, but you can feel its weight and see it move the leaves on a tree. Dark matter is the same. It is the invisible foundation upon which the entire visible universe is built. Without this silent glue, the stars would never have gathered into galaxies, and the galaxies would never have clustered together in the grand patterns we see today. It is the ultimate reassurance that even in the parts of space that look empty, there is a structure, a purpose, and a constant, steadying force. As you settle deeper into the comfort of your bed, you can imagine this invisible web stretching out across the billions of light years, connecting everything in a great, silent network. It is a layering of support that goes all the way up from the pillow beneath your head to the very edges of the observable universe. And as we look out beyond the boundaries of our own galaxy, we see that this invisible thread is pulling on more than just our own stars. It reaches across the immense dark gulf of intergalactic space toward our nearest major neighbor, a great spiral of light that is slowly, steadily answering the call. Across the distance, the Andromeda Galaxy is watching, and the two of us are beginning a long, slow journey toward one another, guided by these same invisible hands. Imagine, if you will, looking out into the deep velvet blackness of the night sky, far beyond the familiar stars of our own Milky Way. Out there, in the immense silence of the intergalactic void, lies a sister galaxy, a grand spiral of light and ancient dust known as Andromeda. For billions of years, she has been our closest major neighbor, a distant, shimmering smudge of light visible to the naked eye on the clearest of nights. But Andromeda is not merely a distant spectator. She is a traveler, and she is making her way toward us in a journey that is as inevitable as the pull of the tide. As you lie there, feeling the weight of your blankets and the steady rhythm of your breath, Consider the scale of this cosmic movement. Andromeda is currently racing toward the Milky Way at a speed of roughly 68 miles per second. To our human ears, 68 miles per second sounds incredibly fast, a blur of motion that would cross entire continents in the blink of an eye. But in the vast, echoing hallways of the universe, this is a gentle, unhurried drift. Space is so immense, and the distance between our two galaxies so great, that this approach happens in a profound slow motion grace that spans eons. Take a soft, slow breath. There is no rush in the cosmos. There is only the patient, enduring work of gravity. This journey will take approximately 4 billion years to complete. It is a timeline so long that it is almost impossible to grasp, a span of time longer than life has existed on our planet. We have plenty of time to rest, to dream, and to simply exist in the quiet of the present. In 4 billion years, our two galaxies will finally meet, and they will begin what astronomers call a gravitational merger. It is easy to hear the word collision and think of something harsh or violent, but a galactic collision is nothing like the impact of two objects on Earth. It is much more like a dance, a slow, swirling waltz where two great spirals of stars begin to circle one another, their gravity reaching out like outstretched hands. They will pass through one another, their shapes stretching and softening as they traded stars and gas in a silent exchange of light. The stars themselves are so far apart from one another that they will not crash. They are like grains of sand separated by miles of open air. They will simply glide past one another, finding new homes in a larger, even more magnificent structure. This merger is not an ending, but a beautiful transformation, a reorganization of the heavens into something new and grand. It is a reminder that in the universe, gravity is not a force of destruction, but a force of union. It brings things together, blending the old into the new, ensuring that nothing is ever truly lost, only changed into a different form of beauty. As Andromeda draws closer over the coming billions of years, the night sky of Earth, should anyone be there to see it, would become a spectacular display of cosmic art. The distant smudge of light would grow into a brilliant glowing arc that spans the entire horizon, a second Milky Way joining our own, to create a sky filled with twice as many stars, twice as much light, and a deeper sense of connection to the rest of the universe. But for tonight, Andromeda remains a quiet, distant promise. She is out there, drifting through the dark, guided by the same invisible threads of gravity that hold you safely in your bed. Everything is moving exactly as it should, at a pace that is perfectly balanced and serene. You are part of this grand, slow-motion story, tucked away in a corner of the galaxy that is safe, stable, and deeply at peace. As we contemplate this meeting of giants, it helps to realize just how much empty space exists even within the busiest parts of the universe, and why this grand encounter is more of a gentle overlapping than a strike. Imagine two clouds of steam merging in a quiet moonlit kitchen, or two swarms of fireflies passing through one another in the deep stillness of a summer twilight. That is the true reality of a galactic collision. It is a collision without impact, a meeting of trillions of objects where almost nothing ever actually touches. This is because The universe is, above all else, incredibly, beautifully empty. The distances between stars are so vast that our minds struggle to even hold the scale of it. Yet in that emptiness, there is a profound sense of peace. If you were to imagine our sun as a tiny grain of sand sitting on your palm, the very nearest star to us would be another grain of sand located over 20 miles away. Between those two tiny specks, there is nothing but the cold, quiet vacuum of space. When the Milky Way and Andromeda finally intermingle, the stars will slide past each other like ships in the night, separated by wide silent oceans of darkness. The odds of two individual stars actually colliding are so small as to be almost zero. It is a graceful, phantom-like experience. Instead of a crash, what happens is a long, slow reorganization of gravity. The spiral arms of our home, those beautiful spinning veils of gas and dust, will be pulled and stretched by the mutual attraction of the two galaxies. They will lose their distinct shapes, swirling together over millions of years until they settle into a new form altogether. The result of this cosmic union won't be another spiral, but a massive, glowing sphere of stars known as an elliptical galaxy. Astronomers sometimes playfully call this future home Milkomeda. In an elliptical galaxy, the stars no longer follow the rigid lanes of a flat disk. Instead, they move in more randomized, three-dimensional orbits, creating a soft, uniform glow that looks like a giant, golden pillow of light in the deep dark. It is a stable, mature state for a galaxy to be in, a place where star formation slows down and the existing stars simply age together in a quiet, collective embrace. This process of merging is happening all across the universe all the time. It is how galaxies grow, how they mature, and how they find their place in the larger structure of the cosmos. As we watch these two giants begin their long-term commitment to one another, we start to see that they aren't just isolated islands of light. They are part of something even bigger, a family of galaxies that move through the void together, bound by the same invisible tethers of gravity. If we pull back even further now, moving our perspective away from the dance of our own galaxy and Andromeda, we begin to see that we are not alone in this corner of the universe. We belong to a small, tight-knit community known as the local group. It is our celestial neighborhood, a place where gravity acts as both the fence and the foundation for a collection of cosmic residents, each moving in harmony with the others, drifting together through the great dark sea of the night. In this vast, silent theater of the stars, we begin to see that even our massive galaxy is just one member of a small, quiet community. This is the local group, our celestial neighborhood. If you could step back far enough to see it all at once, you would see a collection of about 50 galaxies, all tucked together in a pocket of space roughly 10 million light years across. It is a comforting thought to know that in the unimaginable emptiness of the void, we have neighbors, and we have a place where we belong. The Milky Way and the Andromeda Galaxy are the two great anchors of this group, the two largest lanterns in the courtyard. But they are surrounded by a family of smaller, humbler companions. There is the Triangulum Galaxy, a beautiful spiral that is the third largest member, and then there are dozens of dwarf galaxies, small, shimmering clouds of stars with names like the Large and Small Magellanic Clouds, or the SAG-DG. These smaller galaxies often huddle close to their larger neighbors, like children walking beside their parents in a slow, rhythmic procession. They are held in place by the same gentle, invisible threads of gravity that keep your blankets tucked around you tonight. What makes the local group so special is its resilience. You may have heard that the universe is expanding, that space itself is stretching and pushing galaxies away from one another at incredible speeds. And while that is true for the distant reaches of the cosmos, it is not the story here at home. Within the local group, the shared gravity of these 50 galaxies is strong enough to overcome that cosmic expansion. We are bound together so tightly that we remain a single, cohesive unit. While the rest of the universe grows more distant, our neighborhood stays intact, a gravitational sanctuary where the members refuse to drift apart. We are moving through the cosmic sea as a convoy. Every star, every planet, and every person within these 50 galaxies is part of the same Grant journey. We are not just drifting aimlessly, the entire local group is traveling together toward a common destination, guided by the collective weight of everything around us. It is a slow, majestic movement, a glide through the darkness that feels as steady and certain as the turning of the earth. As we continue to pull our perspective further away, the local group begins to shrink. The 50 galaxies that seemed so vast and spread out now begin to look like a tiny cluster of sparkling dust motes huddled together for warmth. We are leaving the familiarity of our immediate neighborhood and entering the realm of the truly immense. Just as a single house is part of a street and a street is part of a city, our local group is merely one small part of a much larger structure. We are ascending now toward the scale of superclusters, where the patterns of the universe begin to reveal themselves as something breathtakingly beautiful, a grand interconnected map of light that the ancients might have called an immeasurable heaven. Imagine, if you will, the perspective shifting once more, drifting so far back that the local group of galaxies, the Milky Way, Andromeda, and all their companions, becomes nothing more than a single shimmering spark in a much larger tapestry. We have arrived at the threshold of Laniaka. In the gentle melodic language of Hawaii, the name Laniaka means immeasurable heaven. It is a name that captures the sheer, breathtaking scale of the structure we inhabit. It is our home on the grandest of scales, a place where the boundaries are defined not by walls or borders, but by the quiet, persistent flow of gravity. Laniaka is what astronomers call a supercluster. It is a vast celestial watershed that spans over 500 million light years. Within its invisible borders, there are approximately 100,000 galaxies. Think of that for a moment as you settle deeper into your pillow. 100,000 entire galaxies, each a home to hundreds of billions of stars, all gathered together in one immense gravitational embrace. From this distance, the individual stars are invisible, and the galaxies themselves look like delicate filaments of silk, glowing softly against the deep velvet blackness of the void. What makes Laniakea so remarkable is how we discovered its shape. It wasn't found by simply taking a photograph, but by mapping the way galaxies move through the darkness. Imagine a great mountain range where the rain falls and the water finds its way into different basins. Scientists tracked the paths of thousands of galaxies and found that they are all flowing in a specific direction. Our Milky Way, along with all its neighbors, is meandering through the dark, following a cosmic current that dictates the rhythm of our journey. This current leads toward a mysterious region known as the Great Attractor. It is a point of immense gravitational influence, a quiet, unseen center that acts as the anchor for our entire supercluster. It isn't a place of chaos or destruction. It is simply a gravitational valley in the landscape of space-time, where the rivers of galaxies naturally converge. Just as a leaf might float down a slow-moving stream, our galaxy is being guided toward this destination by the subtle, persistent pull of mass. It is not a sudden or violent movement, but a graceful, inevitable drift. A journey that has been unfolding for billions of years and will continue for billions more. When you visualize Laniakea, it doesn't look like a solid sphere or a flat disk. Instead, it looks like a feather or perhaps the delicate veins of a leaf. Long, thin tendrils of light stretch out across the emptiness, branching and curving in a way that feels strangely organic, almost like the neural pathways of a resting mind. It is a reminder that even at the largest scales imaginable, the universe follows patterns that feel familiar and comforting. But as vast as Laniakea is, as immeasurable as it may seem, it is not the end of the story. It is merely one branch on a much larger tree. If we pull back even further, until the 100,000 galaxies of Laniakea shrink into a single glowing thread, we begin to see the ultimate architecture of the universe. We are moving now beyond the superclusters and into the realm of the cosmic web, the largest pattern in existence, where gravity has woven the very fabric of reality into a masterpiece of light and shadow, connecting everything in a silent, eternal dance. As we drift further into the silence of the deep cosmos, the scale becomes so vast that the individual galaxies we once marveled at begin to blur into something new. We are no longer looking at stars, or even clusters of stars, but at the very skeleton of the universe. This is the cosmic web, the most immense structure known to science, and perhaps the most beautiful. It is a masterpiece of light and shadow woven together by the patient, tireless hands of gravity over billions of years. If you could step back and see the entire universe at once, you wouldn't see a random mist of matter. Instead, you would see a network of glowing silk. Gravity, acting as the ultimate weaver, has pulled the gas and the dark matter and the galaxies into long, luminous filaments. These strands stretch across the darkness like the threads of a spider's web intersecting at bright nodes where thousands of galaxies congregate in luminous cities of light. It is a sight of profound order and peace, a reminder that even in the infinite reaches of space, there is a design, a rhythm, and a connection. But for every thread of light in this web, there is a corresponding space of shadow. Between these long filaments lie the great voids, vast spherical regions of emptiness where almost nothing exists. Some of these voids are so large that they span hundreds of millions of light years. If you were placed in the center of one, the sky would be almost entirely black, with only the most distant, faint glimmer of a galaxy on the far horizon. These voids are the lungs of the universe, the quiet spaces that allow the structure of the web to take shape. This contrast, the thin, busy lines of matter and the deep, silent expanses of nothingness, creates a texture that is strangely familiar to us. When scientists map this cosmic web, they often remark on how much it resembles the organic structures we find here on Earth. From a distance, the universe looks remarkably like the neural network of a human brain, with its branching pathways and interconnected nodes. Or perhaps it looks like the intricate, porous interior of a sea sponge, or the delicate lattice of a honeycomb. There is something deeply comforting in this realization that the largest thing in existence mirrors the smallest, most intimate parts of life. It suggests a unity of form, a single set of rules that governs the growth of a thought, the structure of a cell, and the layout of the stars. This grand architecture is the result of gravity's long, slow work. Since the beginning of time, gravity has been nudging matter out of the voids and into the filaments, concentrating the energy of the universe into this beautiful, interconnected map. It is a process that happens at a pace so slow it is almost indistinguishable from stillness. It is a gentle, persistent shaping of reality, a pull that never tires and never wavers. But to truly understand how gravity manages to weave such a complex web, we have to look closer at what gravity actually is. We often think of it as a force, a cord that ties one object to another. But the reality is even more poetic. To understand the web, we must understand the fabric it is built upon. We must look at the way space itself isn't just an empty room, but a soft, flexible material that can be bent, curved, and shaped by the presence of mass. It is this curving of the very foundation of the universe that allows the stars to dance and the galaxies to flow. Imagine for a moment that the universe isn't a vast hollow room, but rather a soft, invisible fabric. This material is more delicate than the finest silk, yet stronger than any steel, stretching out in every direction to the very ends of existence. This is the essence of general relativity, the profound realization that space and time are not separate, empty concepts, but are woven together into a single, flexible sheet called space-time. It is the very stage upon which the cosmic dance is performed, a medium that can be bent, stretched, and shaped by everything it holds. When a massive object, like a star or a planet, exists within this fabric, it doesn't just sit on top of it. Because of its weight and its presence, it sinks in. It creates a gentle, sloping curve in the fabric around it, much like a heavy sphere resting in the center of a soft, supportive mattress. The more massive the object, the deeper and wider the curve it creates. This curve is what we have been calling gravity all along. For centuries, we thought of gravity as a pull, a mysterious, tugging force that acted across the distance. But through this lens, we see that gravity is actually geometry. It is the shape of the universe itself. Think of a small marble rolling across that same mattress. If the mattress were perfectly flat, the marble would move in a straight, predictable line. But as it nears the heavy sphere, it begins to follow the slope. It doesn't move toward the center because an invisible hand is grabbing it. It moves that way because that is the only path the ground beneath it provides. It is simply rolling down a hill that it cannot see. This is how the earth stays near the sun and how the moon stays near the earth. They are not being held by chains or ropes. They are simply following the natural, elegant curves of the space they inhabit. An orbit, then, is the most peaceful motion imaginable. It is the act of falling along a curve that never ends, a perpetual glide through a valley that circles a mountain. There is no friction here, no effort, and no resistance. Everything in the cosmos, from the smallest speck of stardust to the most massive galaxy, is just following the contours of this invisible landscape. Even light itself, the fastest thing in existence, must follow these curves. As a beam of starlight passes near a massive sun, it bends ever so slightly, tracing the dip in the fabric before continuing on its way. It is a reminder that in the universe, there are no truly straight lines, only beautiful, sweeping arcs. This fabric is the ultimate quiet connector. It ensures that nothing is ever truly isolated, because every object, no matter how small, creates its own tiny ripple, its own little dimple in the sheet of the universe. You, lying there now, are creating a microscopic curve in the space-time around you. It is a very small curve, but it is there, a gentle signature of your existence written into the foundation of reality. But this fabric is even more mysterious than we first imagined. Because space and time are so intimately woven together, you cannot bend one without affecting the other. When a massive object curves the space around it, it doesn't just change the path of a planet. It also stretches the very seconds and minutes that pass within that space. As the fabric dips and deepens, the rhythm of time itself begins to change, slowing down as it moves through the valleys created by gravity. This connection between the shape of the world and the flow of the clock reveals a universe where time is not a steady, unchanging beat, but a soft, fluid experience that breathes and shifts along with the stars. Imagine for a moment that time is not a rigid, ticking metronome, but a soft, silken thread that can stretch and linger. We often think of a second as something absolute, the same for you, for the moon, and for the most distant stars. But in the presence of gravity's gentle curve, time actually begins to slow its pace. This is one of the most beautiful and quiet secrets of our universe. The closer you are to a massive object, the more time softens and expands. If you were to take two perfectly synchronized clocks and place one on the surface of the earth and the other far out in the silent, empty reaches of deep space, they would eventually drift apart. The clock on Earth, nestled within the planet's gravitational dip, would tick just a tiny bit slower than the one drifting in the void. It is as if the Earth's mass is so comforting that even time itself decides to stay a little longer, moving with a more leisurely rhythm near the ground. This isn't just a poetic thought. It is a fundamental law of our reality known as gravitational time dilation. It has been proven time and again with incredibly precise instruments. Even the satellites that circle our world, providing the signals for our maps and navigation, have to account for this. Because they are further away from the Earth's center, time moves slightly faster for them than it does for us down here. Every day, the systems on those satellites must gently adjust their internal clocks by a few millionths of a second, so they stay in harmony with the slower, heavier time we experience on the surface. Without this tiny correction, our sense of place in the world would slowly drift off course by miles. It is a strange and comforting thought to realize that as you lie here, closer to the heart of the planet, you are moving through time at a slightly different pace than an astronaut on the space station. You are tucked into a pocket of time that is uniquely yours, shaped by the very ground beneath your bed. It suggests that time is not something we are rushed through, but something that responds to our environment, stretching out to give us more room when the universe is heavy and full. As we understand that the fabric of space-time can be bent and stretched like this, we begin to see it as something more than just a stage where things happen. It is a living, flexible medium. And just as a soft fabric can be stretched or compressed, it can also carry ripples. If you were to gently tap a sheet of silk, a wave would travel from your finger to the very edges of the cloth. In the same way, the universe has a way of carrying news across its vast distances. When something truly immense happens in the deep dark of space, when two giants meet or a star finds a new destiny, the fabric of space-time doesn't just bend, it vibrates. These vibrations are the whispers of gravity, moving through the cosmos like ripples on the surface of a still nighttime pond. Imagine for a moment that the universe has a voice, not one that speaks in words or sounds that our ears can catch, but one that speaks in rhythms. When we look at the stars, we usually see light, the bright and constant glow of distant fires. But there is another way to listen to the story of the cosmos, a way to feel the pulse of everything that has ever been. These are gravitational waves, the soft, invisible whispers of gravity moving through the dark. You might think of them as the heartbeat of space itself, a gentle hum that vibrates through the very foundation of reality. Deep in the far reaches of the universe, events of unimaginable scale take place. Two black holes, having circled each other for millions of years in a slow, spiraling dance, finally reach the end of their journey and come together. Or perhaps two neutron stars, objects so dense that a single teaspoon of their matter would weigh as much as a mountain, finally merge into one. In that moment of union, they release a pulse of energy so great that it actually shakes the fabric of the universe. It doesn't just push matter aside. It stretches and squeezes the distance between things. It is a ripple in the silk of space-time, moving outward in every direction like a wave from a stone dropped into a vast obsidian lake. These ripples travel across the void at the speed of light, the fastest pace allowed by the laws of physics. They cross the vast empty stretches between galaxies, passing through colorful nebulae and gliding past the silent sentinels of distant suns. They carry the news of that ancient collision across the eons, traveling for billions of years before they finally reach our small corner of the sky. By the time they arrive here, these waves are incredibly faint, a tiny delicate tremor in the fabric of our world smaller than the width of a single atom. To hear these whispers, we have built vast, quiet machines in the most silent places on Earth. These observatories use beams of light reflected over miles of vacuum to sense when space-time itself is being tugged, even by the smallest fraction. It is as if we have finally learned to feel the pulse of the universe's own breath. It reminds us that everything that happens, no matter how far away or how long ago, leaves a mark. The universe is not a collection of isolated points, but a single, interconnected tapestry that can vibrate from one end to the other. As these cosmic waves wash over our planet, they pass through the mountains, through the deep currents of the oceans, and through the very room where you are resting now. They pass through your pillow and through you, moving with a grace that is completely silent and perfectly harmless. You don't feel them, yet they connect you to events that occurred in the deep past, in galaxies we will never see with our own eyes. It is a quiet, rhythmic reminder that you're a part of a much larger story, a participant in a cosmic conversation that has been going on since the beginning of time. Let that thought settle into your mind like a soft, warm weight. The same space that ripples with the power of merging stars is the same space that holds you safely and securely in your bed. You are floating in a sea of these gentle vibrations, tucked away in a peaceful corner of a universe that is constantly, quietly communicating with itself. As you sink deeper into the comfort of your blankets, you can almost imagine the entire cosmos as a grand, slow-moving symphony, where every movement is intentional and every note is held together by the same invisible threads that keep you grounded and safe. The world is large and the stars are far away, but you are never truly separate from them. You are held in the same fabric, breathing the same silence, drifting in the same beautiful, rhythmic dance of gravity. As you lie here in the stillness of the night, you might begin to realize that gravity is not just a law of physics or a mathematical equation. It is a constant, quiet companion that has been with you since the very first moment of your existence. It is the most loyal of forces, never wavering, never letting go. It is the invisible hand that tucked you into bed tonight, the same way it has tucked the planets into their orbits for billions of years. It is a presence so steady and so reliable that we often forget it is there. Yet it is the very thing that allows us to rest, knowing that the world will stay exactly where we left it when we close our eyes. There is a beautiful, quiet symmetry to this force that we rarely stop to consider. We often think of gravity as something that happens to us, the earth pulling us down, the sun holding our world in place, the moon stirring the seas. But science tells us that gravity is a two-way street, a mutual agreement between all things that possess mass. Every single atom that makes up your body, the carbon in your bones, the iron in your blood, the oxygen in your lungs, possesses its own tiny gravitational field. It is small, almost infinitesimal, but it is real. At this very moment, you are exerting a gentle pull on the world around you. You are pulling on the mattress beneath you, on the walls of your room, and on the trees standing silent in the yard. Your reach extends even further out past the atmosphere and into the velvet dark. You are tugging on the moon as it slides across the sky, and you are even exerting a microscopic pull on the distant ancient stars in the heart of the Milky Way. You are tugging on the universe, and the universe is tugging back. This means you are inextricably linked to the entire cosmos by these invisible, unbreakable threads. There is no part of space-time that does not know you are there. You are not a stranger in a vast, cold void. You are a vital part of the mass and the energy that defines the very shape of the universe. This connection is constant. It doesn't matter how dark the night becomes or how quiet the world feels. You're anchored. You belong here. You're a participant in the great architecture of reality, held in place by a force that is written into the fabric of every grain of dust and every burning sun. Feel the weight of your blankets now. That gentle pressure is gravity's way of reminding you that you are safe. It is the physical sensation of being held by the planet. Take a slow, deep breath, feeling your chest rise and fall in that same rhythmic pulse we see in the tides of the ocean and the orbits of the stars. As you exhale, let go of the day, let go of the thoughts, and let go of the worries. The universe is vast, but it is also very patient. It will continue its grand, silent dance while you sleep, keeping the planets turning and the stars burning, all while holding you securely in your quiet corner of the world. There is nothing more you need to do. The threads are holding, the balance is perfect. The same laws that guide the galaxies are the same laws that keep you tucked in, warm and still. You are home, and you are exactly where you are meant to be. Rest now. In the peace of the silent dance, sleep, sleep, sleep.